Greetings, I'm Batiancila. Today I will showing you the design of our order management system. The foundation of our system is the order class, which is an abstract class. Think of this as an template that holds basic information like the order ID and base amount. Because it is abstract, you cannot create a plain order object. It only exists to provide a common structure for our specific order types. Our system uses inheritance to create a generalization relationship. We have three main types: dine-in order, pickup order, and delivery order. All of them inherit the basic features of the order class, but each one has its own way of calculating the total. For example, the dine-in order adds a service fee, while the pickup order just uses the base price. For the delivery order, we use a composition relationship with the delivery details class. This is a one-to-one multiplicity, meaning each delivery order has exactly one set of details, like the distance and delivery weight. These details belong entirely to the order. If the order is deleted, the delivery details are deleted too. Finally, we use polymorphism to manage everything efficiently. Even though we have different types of orders, we can put all of them in one single list. When the program runs, it automatically knows which calculation used for each order. This makes the system very flexible, allowing us to add new types of orders in the future without changing the main code.
Greetings everyone. Today I will explain our program about an online food delivery platform system. First, we have the abstract class called order. This serves as the blueprint for all types of orders. In our code, you can see abstract class order, private string order ID, private double base amount. These are the two main attributes. Order ID for identifies the order. Base amount for the original price before any additional charges. We also created getter methods like public string get order ID, return order ID. This allows other classes to safely access the data. Now, the most important part is this slide. Public abstract double compute total. This is an abstract method, meaning it has no body. Each subclass will provide its own way of computing the total amount. We also have a shared method, public void process payment, and a system.out at print line total amount pesos plus compute total. This method uses polymorphism because even though compute total is called here, the actual computation depends on which subclass is being used. Next, we have the first subclass, dine-in order. Class dine-in order extends order. Private static final double. Service charge rate 0.10. This class represents orders that are eaten inside the restaurant. Here we added a 10% service charge. The computation is shown in double service charge is equals to get base amount. Serve time service charge rate. Return get base amount plus service charge. So the formula is base amount plus service charge. We also override the payment method to make the output more detailed. System.out.println order type dine-in. System.out.println service charge plus service pesos plus service charge. This helps the user clearly see the breakdown of their payment. Then we have the second subclass pickup order. Class pickup order extends order. This represents orders that customers pick up. Its computation is simpler. Public double compute total return get base amount. There are no additional charges, so the total is just the base amount. We also override the process to display system.out.println order type pickup. System.out.println no additional charges.
Greetings everyone, I'm DEVERA, and For my part of the presentation, I will be explaining two classes in our program, the Delivery Details class and the Delivery Order class. Let me start with the Delivery Detail class. So, the class Delivery Details, this line declares the class name Delivery Details. Notice that it does not say extends anything, meaning this class does not inherit from order or any other class. It stands on its own as a helper class whose only job is to store and compute delivery specific information. Private double distance km, private double rate per km. Here we declare two private attributes. The first one is the distance kms. This stores the delivery distance in kilometers. The second one is rate per km, stores how much is charged per kilometer. Both are double because they can hold these decimal values. They are declared private to follow encapsulation, meaning no outside class can directly access or modify those values. So, public delivery details double distance kilometer double rate per kilometer. This dot distance km is equals distance km. This dot rate per kilometer is equals to rate per kilometer. This is the constructor. When a delivery details object is created, we pass in two values, the distance and the rate. This keyword is used to distinguish between the class attribute and the parameter that was passed in. So this distance kilometer refers to the attribute of the object, while distance kilometer on the right side refers to the value that was passed in. Public double get distance kilometer return distance kilometer. Public double get rate per kilometer return rate per kilometer. These are the getter methods. Since the attributes are private, other classes cannot access them directly. This method allow other parts of the program to retrieve the distance and rate values in a controlled way. This is part of proper encapsulation. Public double compute delivery fee return distance kilometer times rate per kilometer. This is the most important method in this class. Compute delivery fee. It is simply multiplies the distance by the rate per kilometer to get the total delivery fee. For example, in our test case 3 is the distance is 5 kilometers and the rate is 20 pesos per kilometer. So 5 times 20 gives us 100 pesos as the delivery fee. Now let's move on to the delivery order class. Delivery class delivery order extends order. This line declares the delivery order class and shows that it extends order. This means that the delivery order is a subclass of order. It inherits the order ID and base amount attributes as well as the methods defined in the order class. This is inheritance in action. So private delivery details, this line declares private attribute of type delivery details. This is what establishes the composition relationship. Delivery order has a delivery details. The delivery specific data is not stored directly inside the delivery order. Instead, it is delegated to a separate delivery details object. This keeps each class focused on one responsibility. So public delivery order, string order ID double base amount, double distance kilometer, double rate per kilometer. This is the constructor of delivery order. It accepts four parameters: the order ID, the base amount, the distance, and the rate per kilometer. It needs all four because it has to initialize both inherited order data and the delivery specific data. Super order ID, base amount. This line calls the constructor of the parent class, which is order. The super keyword pass the order ID and base amount up to order so that the inherited attributes are properly initialized. This must always be first line inside a subclass constructor. This dot delivery details, new delivery details, distance kilometer, rate per kilometer. This line creates a new delivery details object and assigns it to the delivery details attributes. We pass in the distance and rate per kilometer, so at the moment a delivery order is created, delivery details is also created inside it. They are always together. Public, deve- delivery details get delivery details, return delivery details. This is the getter method for the delivery details object. It allows other parts of the program to access the delivery details component of this order if needed. Override public double compute total, return get base amount plus delivery details that compute delivery fee. This is the overridden compute total method. The override annotation tells Java that this method is replacing the abstract version from the parent class order. Inside it, it calls getBase method, which retrieves the base amount from the parent class and adds the result of delivery details, compute delivery fee, so the total is the base amount plus the delivery fee. In, in test case 3, that is 400 plus 100, giving us a total of 500. Override public void process payment double delivery fee delivery details compute delivery fee. This begins the overridden process payment method again. The override annotation means we are replacing the version from the parent class. The first line is inside method stores the computed delivery fee in a local variable called delivery fee, so we can display it in output. Sysout process payment for order plus get order ID. Sysout order type equals delivery. Sysout base amount PHP plus string get base amount. These three lines print the order ID, the order type, and the base amount. We use string format to make sure that the numbers are always displayed with two decimal places so it looks clean and professional. Sysout distance delivery details that get distance plus km. This line, these three lines is these three lines prints the delivery specific details, the distance and the rate per kilometer, and the computed delivery fee. Notice that we are calling delivery details that get distance kilometer and delivery details get rate per kilometer. We are accessing the delivery details object to get these values, which stores the composition relationship working at a runtime. So in this line, finally, the last two print statement display the total amount and the payment status compute. Total is called here to get the final bill, the closing braces, and process payment method in the entire delivery order. And that's all for my part. Thank you.
Dangal greetings everyone. My name is Shane Miranda Dulia and today I will be explaining the main class of our online food delivery platform system. First, we import two important classes. Import java.util.arraylist and import java.util.list. These are the used to store multiple objects in a collection. Specifically, we use list to hold different types of orders such as dine-in, pick-up, and delivery. Next, we define our main class. Public class main, this is the entry point of our program. Inside it, we have the main method, public static void main string args. This is where the program starts executing. Next, we declare a list. List orders is equal to new array list. Here we create a list that can store objects of the type order. Since order is the parent class, this allows us to store different subclasses like dine-in order, pick-up order, and delivery order in the one collection. This demonstrates polymorphism. Then we add our test cases. First, order.add new dine-in order test case 1 500. This creates a new dine-in order object with the order ID test case 1 and a base amount of 500 pesos. This represents a dine-in transaction where a 10% service charge will be applied. Next, orders.add new pickup order test case to 300. This creates a pickup order object with order ID test case 2 or TC2 and a base amount of 300 pesos. Pickup orders do not have additional charges. Then orders add new delivery order TC3 400 520. This creates a delivery order object with order ID TC3, a base amount of 400 pesos, a distance of 5 kilometers, and weight of 20 pesos per kilometer. This value will be used to compute the delivery fee. After that, we print the header. This part this is used to display a title for our system which improves the readability of the output. Next, we process all the orders using a loop. For order, colon order. This is for each loop that goes through each order in the list. Even though the objects are different types, they are treated as order objects. This is another example of polymorphism. Inside the loop, we print the test case label, system.out.print test case plus order.get order ID plus the bracket. This shows which test case is currently being processed. Then we call order.processPayment. This method processes the payment and displays the details. The actual behavior depends on the type of order, demonstrating dynamic method overriding. Finally, after processing all the orders, we print a closing message. This confirms that all the transactions have been completed successfully. In summary, the main class demonstrates how multiple orders types can be handled in a single collection and processed using a unified workflow while still allowing each type of behave differently. Now let's move on to the output of our program. Now I will explain the output of our food delivery platform system. At the top, we display the system title, Online Food Delivery Platform Order System. This serves as header to clearly identify the program and make its output organized and easy to read. Next, the system processes each order based on the given test cases. For the test case 1 or TC1, this represents a dine-in order. The base amount is 500 pesos. Since dine-in orders include a 10% service charge, the system calculates an additional 50 pesos. This results in a total amount of 550 pesos. This output shows all details including the order type, base amount, service charge, and final total. And finally, the system confirms that the payment was successful. For the test case 2 or test TC2, this represents a pickup order. The base amount is 300 pesos. Unlike dine-in and delivery, pickup orders do not have any additional charges. Therefore, the total amount remains 300 pesos. The system clearly indicates that there are no additional charges and confirms that the payment is successful. For the test case 3 or TC3, this represents a delivery order. Based on the amount, 400 pesos, with a delivery distance of 500 kilometers and the rate of 20 pesos per kilometer, the system calculates the delivery fee by multiplying the distance and rate, which results in 100 pesos. This delivery fee is added to the base amount, giving a total of 500 pesos. All relevant details such as distance, rate, delivery fee, and total amount are displayed. The system then confirms that the payment is successful. After process all the test case, the program displays a final message. All orders are processed successfully. This indicates that all transactions were complete without errors. And that's all po. Thank you for listening.